How to determine which fundamental force dominates at a given scale. Step 1. Determine the distance between the objects in question. Is the scale a macro scale or a micro scale? Step 2. Determine which force, gravity or the electromagnetic force, dominates. Gravity dominates at a macro scale, but electromagnetic forces dominate at a micro scale. What are the fundamental forces, macro scale and micro scale? Fundamental forces. There are four fundamental forces: gravity, the strong nuclear force, the electromagnetic force, and the weak nuclear force. This lesson focuses primarily on gravity and electromagnetic force. While gravity is the fundamental force we feel the most, it is actually the weakest of the four fundamental forces. The reason we feel gravity more is that it dominates at a macro scale, but the other fundamental forces dominate on a micro scale. Macro scale. Distances at a macro scale are large enough to be seen by the eye, and include distances that are extremely large. Micro scale. Distances at a micro scale are too small to be seen by the eye. This includes distances between atoms. We will use these steps and definitions to determine which fundamental force, gravity or electromagnetic force, dominates at a given scale in the following two examples. Examples determining which fundamental force dominates at a given scale. Example 1. Two planets are 1.55 times 10 to the power of 8 km apart. Which force would dominate at this scale, gravity or the electromagnetic force? Step 1. Determine the distance between the objects in question. Is the scale a macro scale or a micro scale? The distance between the planets is 1.55 times 10 to the power of 8 km, which is a very large distance. This distance is at a macro scale. Step 2. Determine which force, gravity or the electromagnetic force, dominates. Gravity dominates at a macro scale, but electromagnetic forces dominate at a micro scale. Since we are concerned with a macro scale distance, we can conclude that gravity dominates at this scale. Example 2. Two hydrogen atoms in a hydrogen molecule are 1 times 10 to the power of -12 meters apart. Which force would dominate at this scale, gravity or the electromagnetic force? Step 1. Determine the distance between the objects in question. Is the scale a macro scale or a micro scale? The distance between the atoms is 1 times 10 to the power of -12, which is a very small distance. We cannot see atoms with our eyes, and so this distance is at a micro scale. Step 2. Determine which force, gravity or an electromagnetic force, dominates. Gravity dominates at a macro scale, but electromagnetic forces dominate at a micro scale. Since we are concerned with a micro scale distance, we can conclude that the electromagnetic force dominates at this scale. So, electromagnetism cannot replace gravity. Although electromagnetism is a stronger force than gravity, it has a key difference: it has both positive and negative charges, which tend to cancel each other out over large distances. Gravity, on the other hand, only has one type of charge, which means its effects accumulate over large distances. Here's why electromagnetism can't replace gravity. Charge cancellation. In large objects like planets or stars, the positive and negative charges are roughly balanced, leading to a net cancellation of the electromagnetic force. This allows gravity to dominate on large scales. Weak force. While electromagnetism is stronger than gravity at small distances, gravity's effects accumulate over larger distances due to its lack of charge cancellation. This makes gravity the dominant force for celestial bodies. While there are theories that attempt to unify gravity and electromagnetism, such as some theories of quantum gravity, these are still speculative and haven't been experimentally confirmed. So while flat Earth deny the existence of gravity, all other forces and hypothetical explanations flerfs attempt to replace gravity with fail to work. Density isn't a force and doesn't have a vector of direction. Buoyancy requires gravity to work, and electromagnetism fails to dominate at any scale over the micro scale. The experimental evidence like Cavendish, Pound-Rebka, Pound-Snyder, and the Hafele and Keating experiment are some of many examples that had results confirming gravity and general relativity. That being said, gravity has been calculated, tested, and empirically proven, something that has never been done when it comes to the flat Earth. Now let's see how many flerfs will be crying in the comments. Thanks for watching, see you next time.
Ah, yes, the good stuff. Always sweeten my coffee with the tears of flerfs.